So these are coordinates x bar and y bar attached to the rectangle, which has a width A and a height B. And we'll use the local node numbering scheme starting in the lower left-hand corner, 1, 2, 3, 4. And if we use our basis function vector as 1xy, xy, then we'll go ahead and develop the shape functions. So, or the element stiffness matrix. So let's go ahead and do that in Mathematica. Continuing basically, or starting with what we did for the triangle last time. So this is the code from last time where I had developed it for a triangle. So we're just going to make some modifications here. So we have 1x, y. Now we have an additional term, x times y. Okay, and then we need to evaluate it at the nodes. So in this case, the nodes is going to be 0, 0, A0, AB, and 0. Oh, sorry. The fourth node is x equals 0, y equals b. So there's our A matrix and X vector. So then our shape functions look like that. Okay. Our B matrix is the derivatives of the shape functions, right? With respect to X, with respect to Y, and then the shape functions themselves. In this case, we'll use the same data that we used before. So we'll have A1, A22 on the diagonal and all the other terms 0. And then we'll do our integration. So in this case, we're integrating over y first. So in that case, it's a rectangle. So we're just going to go from 0 to b in the y direction and 0 to a in the x direction. And ultimately, then that's our stiffness matrix, or a little bit simpler form, which we'll use later, is if we just have simply k on the diagonal. Then this is what it is. Okay, so going back to the notes then. Our element stiffness matrix, if we have the data A11, A22, then it looks like this. So that was the first one we derived, and then if A1 1 equals A22 equals, we'll say KE, then tell you what, in the interest of time, I'm not going to write that out, but what I'll do is I'll publish the Mathematica notebook because we just derived it and it's symbolic, so if you need the exact things, you can get it from there. And we are going to work a full example in 2D, but we got a couple of other things to talk about. The first of which is, right, if we